Hey kids, welcome to the last week before spring break, the last week of this 9 weeks. So we're going to real quickly look at a couple of three lessons about soil because it's important that you know these things, especially not so much in seventh, but in eighth grade. Okay, so as you can see, it says by the end of this lesson, so by like Thursday, you should be able to describe the physical and chemical characteristics, back to those two words again, of soil layers and identify the factors that affect soil formation, including how living things affect it. So by the time we are done this week, you should be able to identify factors that affect how the soil develops, okay, how the soil is made, including living things. Second item, should be able to describe a typical soil profile. And that's a term you don't know yet. You will learn it today. You can explain how soil characteristics, again, things, ways to describe the soil, are influenced, okay, how they're changed by the process of soil formation and living things. And then lastly, you need to know these four terms: soil, humus, okay, not hummus like you eat from the grocery store, but humus, a soil profile, and soil horizon. Okay, and this actually is a standard. Soil is unconsolidated material that contains nutrient, matter, and weathered rock. So that is a standard that the state of Ohio wants us to know. And then, of course, again, rocks, minerals, and soils have common and practical uses. All right, so let's just talk about this, these little prediction questions. Soil contains air and water. What do you think? Air might confuse you, I don't know, but air and water, that is true. Okay, we've talked about this already in the goals. Soil does not contain living things. Well, think about the worms and everything. So that would be false. Soils are the same from place to place. You know this answer too. Do you think our soil that we have here in Marion, Ohio is the same as it is in Arizona or up in Alaska? So I'm going with false on that one. And then climate can affect how fertile. That means how well things grow in your soil. I'm going with true on that one. All right. So here's a little ant farm, ant colony. It says, how might the burrows formed by ants affect the soil? This is obviously just like a toy miniature one, but out in real life. Well, all animals can burrow and loosen and mix the soil. And we'll get into that more as we go through. All right, we're going to go through that. All right, our first important point of the day: what causes soil to form? Okay, here's an important definition. This will be one of your questions. Soil is a loose mixture of small rock fragments. That's one thing. So small rock fragments, weathered rock, organic matter, so something that's been living, water, and air. Those four things, you're going to have to almost memorize that. So weathered rock, rock fragments, organic matter, water, and air. That supports the growth of vegetation, plants. Okay, so the first step in forming the soil is the weathering of the parent rock. Okay, that's the base rock. Okay, and that is the source of inorganic soil particles. Now up here, I know it says organic, but both are going to be combined. So the first step is the weathering of the rock. Okay, so if we look at this nice diagram, okay, soil begins to form. Okay, you see the organic matter there, the little plants. Okay, and then horizons form. We'll get into the horizons in a little bit. They're labeled by letters. Okay, and then lastly, we have well-developed soil. So those are the four steps, and we'll go through that more and more each day. Okay, soil usually forms right above the parent rock that it is made from. And it takes a very, very long time, because think how long it takes for that parent rock to break down. And then those over time, lots of time, those little pieces of rock mix with organic matter, plants, etc., to form the soil. Okay, so we got a really nice picture here. Okay, so up above the ground, you see the snails and the grass and all of that. So the soil formation begins when the parent rock weathers, it won't show my mouse, parent rock weathers into small fragments. And if you look at that first arrow, you see the small rock pieces. Then the plant roots grow and further break down sediment. We talked about that maybe just a teeny bit during rocks, okay? And then lastly, the burrowing animals increase it, okay? So they increase the rate, how fast it's happening. They mix the soil, and then that allows air in, they bring sediment down, and it allows everything to be mixed together. All right. There are things called decomposers. And as it says here, such as bacteria and fungi. Well, that would be like mushrooms, okay? But there are things called decomposers that live in the soil. And these decomposers perform the important task of breaking down the remains of plants and animals. So when anything dies, and unfortunately in nature that happens, these decomposers break it down. Okay? Those remains are called humus, okay? And they are found in the top layer of the soil, okay? So those organic remains, the decomposers break down the remains, leaves, grass, dead animals, whatever, and that is called humus, and they're found in the top layer of the soil, okay? So the job that humus does is it provides plants with nutrients that they need to grow, which is obviously a good thing. And then decomposers break them down when they die, and the nutrients are returned to the soil. So it's just a circle that continues to continues when things grow. So humus provides the plants with nutrients. The plants grow. They ultimately die. The decomposers break them down, and it just goes around in a circle again. Okay? Larger animals, earthworms, ground moles, those type things, live in the soil, and so they loosen and mix it up when they burrow down into the ground. And that increases and keeps going on until the amount of air in the soil improves the fertility. And I'm sorry, but if I hit the hide button for some reason, it stops recording. So I apologize. All right, so let's look at these questions because they're good ones. How might a fallen leaf eventually become part of a soil? What do you think? Well, okay, so the leaf falls, and then that term decomposers, they break down the leaf. It ultimately becomes humus. Then that organic matter mixes with the weathered rock, and it forms soil. Okay, if you look, well, let's do the next question next. How do decomposers and plants cycle nutrients in the soil? This is a great question, and you'll have it again this week sometime. Decomposers add the nutrients to the soil when they break down the organic matter. So when those plants or anything living, you see a grasshopper there, a praying mantis, whatever it is, when they die, the decomposers break that down. So then the plants take those nutrients in through their roots. Okay. Ultimately, the plants are going to die. The decomposers break those down again, and it just keeps going in a circle. Okay. All right. What factors determine how long it takes for soils to form? Well, it takes a long, 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 long time. Okay. But the major factors are the type of rock that's being broken down, the climate. Now, we need to talk about climate here. Climate is not just one day's temperature. Like, I don't know what it's supposed to be today, the high, but say 60 degrees in Marion today. Okay. That's not climate, that's temperature. Climate is the weather over a long period of time. Topography is another word I'm sure you probably don't know. Topography means how flat or hilly or mountainous something is. And then lastly, the plants and animals. Okay, so the weathering of the rock depends on the minerals it's made of. As it says here, sedimentary rock weathers faster than metamorphic. Okay, just by the way it's made. Okay, it's structure, composition, if we remember from the last lesson. Okay, so soil usually develops more quickly in a warm or wet area than in cold and dry areas. So they're giving you a picture here of a nice warm, wet area. Okay, and obviously it develops better in flatter areas where erosion is not an issue because of gravity. And then also, of course, plant roots are going to hold things in place, which would allow soil to develop more quickly. Okay, so areas teeming, that means with a lot of life, different life forms, have higher rates of decomposition and mixing. For instance, this forest. Okay, so let's look at this chart. This is important. Some possible characteristics of an area where soil would develop quickly or soil would develop slowly. This is a really good table. Okay, so where soil would be developed quickly, somewhere flat or a valley in between mountains with moderate precipitation, so some rain, but not like flooding, and a warmer climate. Okay, lots of plants and animals. That's what that statement up above meant. Okay, you have plants digging it up, plus decomposers breaking those plants and animals down. And some type of rock that would weather quickly, probably sedimentary. Okay, develop slowly are steep slopes, so like mountain areas. Okay, cold, dry climates. That's not a good thing. Very few plants and animals, so the opposite of lots of plants and animals, and one that weathers slowly, so we're looking more metamorphic there. Okay, last thing here, and then we'll be done. The soil horizons. Okay, so a vertical section of the soil that shows all the different layers is what's called a profile. Okay, so that picture is a soil profile. The picture is the profile. The actual names of them are the horizons. So each layer in the soil profile that has different physical properties is a soil horizon. Different physical properties. We've gone over that for a lot of months. So the A horizon has the most organic material. The most living things are in the A horizon. The B horizon does not contain as much humus and organic material. It's next as you go deeper into the earth. And then C is the least developed. It has the most of the rock fragments and hardly any organic matter at all. Okay, so if we look at this picture, it shows the A horizon, then the B horizon underneath it, and then C. So the question says, which contains the largest rocks? Well, it is C because they haven't been broken down yet. All right, we will stop there. I know it was longer than I usually like to do, but please take your time and listen to this and then answer the questions. You, of course, may redo them if you need to, and then we'll finish this presentation part up on Tuesday. All right, have a good one.